Alright, so carrying on with a few more examples about angle of elevation and depression. And again, remembering that angle of elevation is always something that you measure from the ground up, so you're moving upwards. And angle of depression is always from the horizon down. So let's take a look at the next two problems. Little Johnny's holding onto a balloon that is blowing in the wind. Alright, so we've got little Johnny. He's holding onto a balloon and it's blowing in the wind. So I'm going to put the balloon up there. He looks at the balloon at an angle of elevation of 20 degrees. So what does that mean again? So remember, angle of elevation is always looking up. So you want to think about from a horizontal ground level looking up. And it doesn't necessarily have to be the ground, but in this case just from his hand. The upward angle there is 20 degrees. And there we have a right angle triangle. So one of the questions we're asking is how much higher is the balloon over Johnny's head? So we want to know this side here, how much higher above his head, well, above his hand that he's holding it, we'll make an approximation here, is the balloon. So 2 meters on the string, that's that length there, it's the hypotenuse. So we have our right angle triangle, and we are, again, kind of making some assumptions just about this right angle triangle. And we want to find our, I won't label it h, that's probably confusing because we think about hypotenuse being h, but we'll call it x, the unknown, the height. Now this is the opposite side to the 20 degrees, and this is the hypotenuse. So we're dealing with so. And here you're looking for opposite, so we're going to be timesing that. So you've got sine 20 times 2, and that gives us 0.68 meters. So the balloon is 0.68 meters above, his head, or where he's holding it anyways. Okay, Coyote is standing at the edge of a cliff. She scans the canyon below and sees a rabbit at an angle of depression of 78 degrees. So we've got a cliff, go along a little ways on the ground, and we see a rabbit, big jackrabbit with big ears, big tail, and there's a coyote at the top. Again, not the best drawer, but that's okay. Approximate here. We've got our coyote, it's at the top, and it's looking down at an angle of depression of 78 degrees. So again, think about your horizontal, your horizon, and it's looking down to the rabbit at an angle of 78 degrees. So there's two ways to go about finding an angle inside of a right angle triangle, which is this guy here. And one is to use parallel line rules and know that these are alternate angles, so I could have 78 here, and I could also have 78 down here. But I'm going to show the other one in this example. So remind ourselves that the horizon and the vertical here are going to make 90 degrees. So both of these two angles together have to add up to 90 degrees. If I have 78 here, that means I need to have 12 there, because that's 90 minus 78 equals 12. So I've got 12 degrees there. And a rabbit is 2.5 meters from the cliff, which is fine. So we need to figure out a couple of questions here. How high up is the cliff? That's our first one. And the next question is going to be, if she wanted to jump down onto the rabbit, how far would she have to fly through the air to do that? So we'll solve for x first. X, as we look at this, is going to involve using the 12 degrees, the opposite side of the triangle, and the adjacent side, so we're going to use TOA, tangent. And we're looking for the adjacent, so let's cover that up. So remember here, you need to make yourself a nice fraction that looks just like that with the opposite on top. 2.5 over tangent of 12. And that gives us an answer of 11.76 meters, or 11.8 meters. So we can use, if we wanted to, Pythagoras here. Now that we know that this side is 11.76 meters, you've got two sides, you could use Pythagoras. 11.6 squared plus 2.5 squared, square root. In the calculator quickly on the side, that's going to give us 12.02 meters for this distance here, call it y. But we can also still use trigonometry. Doesn't really matter, there's two ways to do this. So we still have the opposite side of the triangle, and now we're looking for the hypotenuse. So to find y using trigonometry, we would use so. And here we're looking for the hypotenuse, we cover that up. So again, we need to make a fraction using the opposite. So 2.5 divided by sine of 12. And when you plug this into the calculator, you also get 12.02 meters. So the distance straight through the air between the coyote and the rabbit is 12.02 meters. So I'm not sure that it would be safe for a coyote to jump that far down, but I guess coyotes would figure that out. They're pretty smart. So keep in mind, you've got multiple ways to solve problems. Sort of like I did here, if your angle of depression is 78 degrees, you can use that minus 90 to get the angle at the top of the right angle triangle, and then you can solve for things. Or, like I did in the previous example with the albatross, using alternate angles. If you have an angle of depression of 35 degrees, you can use the alt angles of the two parallel lines, and know that the angle of depression is 35, the angle of elevation will also be 35. So a couple of ways to approach those problems, and whatever is more intuitive for you will work.